The laser printer. It turns digital documents into printed pages. Very fast. The printer uses a laser, but this laser never actually touches the page. In fact, the laser's job is to help create an image of each document. An image made of toner, a powder engineered to stick to the page, thanks to the ingenious use of static electricity. But how does it work? The laser printer. Circuit board. Laser unit. Print cartridge. When a digital document is sent to the printer's circuit board instructs the laser beam to send pulses of light into the print cartridge. That's where a laser beam and static electricity turn a digital image into an image that can be printed on paper. But to find out how, it's time to take it apart. Inside the print cartridge are two main components, the drum and the toner hopper. When a print job starts, the drum begins to turn. It brushes against an electrically charged roller that coats the drum's surface with negative charges of electricity. Electricity sitting on a surface. That is static electricity. The drum has a light-sensitive surface. And as it turns, it gets hit by a pulsing laser beam. Wherever that tiny laser beam hits, it destroys a negative charge of electricity. That creates a neutral space on the drum's surface. These neutral spaces are important. As the laser works line by line, zapping the drum 1 million times per second, it creates more and more neutral spaces, until they form an image of the document, right on the drum. For that drum to print the image onto the paper, it needs to fill those neutral spaces with toner. This happens by stirring the toner inside the hopper. The toner is engineered so that the friction from the stirring generates static electricity. A negative charge of electricity sits on the surface of each toner particle. So how does the toner get to the drum? Just outside the hopper, there's a roller that's covered with toner. As the drum turns past this roller, toner has no choice. Since the toner carries a negative charge, it's attracted to the neutral spaces on the drum. It obeys the laws of physics and jumps onto those neutral spaces each time the drum rolls past it. At the same time, the toner is repelled by the negative charges that cover the rest of the drum, so the toner only sticks to the spaces hit by the laser. Now the toner forms a mirror image of the document on the surface of the drum. While all this is happening, the printer is charging a piece of paper with positive electrical charges. The rolling drum carries its toner image down onto the paper. And this is the moment of truth. According to the laws of physics, that positive charge on the paper attracts the negatively charged toner with greater force than those neutral spaces on the drum. That greater force of attraction pulls the toner off the drum and onto the page. Now the image of that text is on the paper. One last roller heats up to 200 degrees Celsius. Its job is to melt the toner permanently onto the paper to create a printed page. The laser printer, an ingenious device. Using the precision of a laser beam to manipulate static electricity, it can print high-quality documents in a flash, as many as 27 pages per minute.
This program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. There's not a lot of on the outside of the average inkjet printer. But open it up, it's a different story. The first order of business is the paper. A paper grabber feeds sheets of paper to the printer. And there's a roller which advances the paper during printing. These cartridges and black tubes make up the ink distribution system. But this is the heart of the machine, the printhead assembly that fires ink droplets on paper. A belt connects the printhead assembly to a motor. This circuitry coordinates the mechanics of printing and decodes information sent from the computer. Its job is to maintain a smooth relationship between the paper, the printhead, and the inks. With less than a teaspoon of ink, a single cartridge can fire 900 million droplets, enough to print hundreds of pages. So how does the printer manage this technical feat? 4 small motors play a major role. There's the motor that runs the paper grabber, and another that feeds the sheets of paper into the printer. A third motor moves the printhead assembly back and forth across the paper, and this one activates the ink pump. These 4 motors coordinate to make things run smoothly. Their smooth operation really pays off when the printhead comes into play. The head is made of silicone, easy to shape and sculpt into the 3,900 tiny nozzles that fit on the printhead. A nozzle really works like a kettle. Inside, an electric current quickly heats up a tiny element. When it's super hot, the ink boils and vaporizes. So it expands. As it expands, it forces a droplet of ink out of the nozzle. The heating element turns off, and fresh ink from the cartridge rushes in to refill the nozzle. It happens incredibly fast, but speed isn't everything. Timing is also crucial. Every single droplet must be shot at precisely the right moment to form text and images on the page. As the printhead skims about 0.04 of an inch above the paper, the printed circuit board orchestrates the ink shooting sequence so that millions of individual droplets always hit their bullseye. Wow, talk about having the right stuff.